So these are your strategies for solving. Okay. Your first strategy is, all right, we have our left-hand side of the equation and we have our right-hand side of the equation. If we can write each side with the same base, okay, then what that enables us to do is those bases will do what? If we have the same base, they do what? They cancel each other out. You remember how we do our inverses, how they cancel out? This would work the same way. If we have the same base on each side, then what happens is they will cancel each other out, and then those powers will drop down. Then your powers will drop down and they will become part of that equation. Then you have an ability then to solve. Okay? Then you would have the ability to get to your x and solve for it. Okay? Remember that your b cannot be equal to 0 because if it's 0, do we even have anything? Well, no. So that's common sense, and b will not be equal to 1. Okay? So that is your first strategy. Okay? Your second strategy is that you can introduce your log into the equation, right? So remember, equations, we manipulate them to help us, right? We bring in things to help us. That's what we do with the log. And I can do that, and you can do that. If you bring a log in on the right-hand side and you bring it in on the left-hand side, have you changed anything? You haven't really changed anything because you've done the same thing on both sides. So you've kept it equal. It still maintains that equality. So that is another strategy that we will use when we solve these, okay? All right, so we're going to see just exactly how that strategy works for us. We have the equation 6 times 4 to the x equals 96. Now, when you are solving these, you're going to think the way you've always solved about equations. You've got to get the variable isolated on one side, right? So you're going to do these the same way. So if you have 6 times 4 to the x equals 96, what would be the first thing you would need to get rid of to get that variable by itself? The 6. And how would we do that? We would divide it. So we're going to do that on both sides. So those would cancel. So we have 4 to the x power, and then 96 divided by 6 would be 16. All right. So on my left-hand side, I've got a base of 4. I've got a base of 4. Okay. Well, over here I have a 16. Could I write 16 as a base 4? I could. 16 is the same as what? 4 squared. So I would rewrite this as 4 to the x equals 4 squared. I have the same base on each side, so now what can I do? Those 4's go, and then we're left with what? X equals 2. Okay? And you can kind of see that, right? What is 4 raised to the second power? 16. Okay? So that's how your strategy works. All right? So this is a quick one for you to kind of actually see that, in fact, you could, I'm sure some of you guessed that before we even finished it. You could see that 4 squared was 16. Okay? Let's try example B. I'll write that one down. So we have 5 to the 4x equals 125 to the x minus 1. So let's see what we can do with that one. All right, so on my left-hand side I have a 5. And on the right-hand side we have a 125. Okay. We need a 5. Can we rewrite 125 with a base of 5? Yes. 5 to the what power would give us 125? 5 to the third power. So we're going to rewrite that 125 as 5 to the third power. Okay? We still have in the up in the exponent, we still have the x minus 1, so we will multiply that. Eventually, we will multiply that with the 3 that we brought up. So that's still up there. That's still a part of the equation. Now, what can we do?
We have the same base, so we cancel out the 5.
We have the same base, so they're gone. They've canceled each other out. So now I have a 4x equal to 3 times my x minus 1. So see how nice that is? Those x's are up as an exponent, but when we use this strategy, we can drop them down. And now it's just like a regular equation, and we're able then to solve it. What do I need to do next? Distribute. So that would be a 3x minus 3, and then solve that. What's that going to give you?
X equals -4.
Negative. Negative 3? Okay. All right. So, a really good strategy to use with your exponential equations. It takes that exponent and drops it down, and then it's just like you've always done when you're solving. Okay? So when we cannot rewrite with the same base, we're going to move on to strategy number 2. Okay? And remember that your strategy number 2 was we will bring in, that's where we'll introduce the log and we'll add the log to each side. Okay? So we're going to take a look at 3 to the x equals 32. So what we're going to do first is we're just going to kind of eyeball this and kind of estimate what we should get, and then we'll kind of know that at the end if we're correct or not. So if they want you to estimate it, well, you have 32. 3 to the x equals 32. Well, we know 3 cubed is 27, and we know 3 to the 4th is 81. So you see that 32 is what? 32 falls in between those, right? So our answer is going to be probably 3 point something, right? 3 point something? Okay, so that's just your little estimate. All right, so here's what we're going to do. We cannot rewrite 32 as a base 3, obviously, okay? So, well, that's okay. We still have another way to approach this, right? Which is to use that second strategy, which is to bring in the log. So that's what we're going to do. So I'm going to rewrite, and I'm going to add the log to both sides. So I'm going to do the log of 3 to the x equals log of 32. All right, now I'm going to take a look at that log of 3 to the x power. Can I rewrite that?
Yes.
I sure can. What can I do?
Move the x to the front.
I can use my power property, and I'm going to move my power to the front. And now I'm going to have a rewrite of x times my log of 3 equals my log of 32. And what do we ultimately want to do is we want to solve for x. Our power property enabled us to take it from being an exponent and dropping it down into the actual equation itself. And now we can get at it and we can actually solve for it. We can isolate it. How are we going to isolate it?
Divide.
Divide by what?
Log 3.
Divide by log 3, absolutely. Okay, so our log 3's will cancel over here. Here's my x isolated equals. Now, you'll have to go to your calculator. You'll have to put this in. You notice that when we brought the log in, we brought it in as a base 10, so that enables us to put it into the calculator. Okay, so if we take log of 32 and divide that by log of 3, make sure you put it in the calculator correctly. Make sure you close the parenthesis after the 32, because if you don't close it, it'll mess you up. You've got to close that out. What are we getting? Are we getting something in between that 3 and 4?
Yes.
Yes, we're getting what? 3 point what? 3.155. They asked us to go to 3 decimal places, right? So we're going to go out to 3.155.
So not getting that at all.
Okay. Whoops. All right, so let's do that. So let's introduce that log. Keep forgetting to. So log of 4 to the x minus 2 equals log of 35.6. So again, what are we able to do? Yeah. We're able to use our power property. Remember I told you way back when we first saw that we were going to use that? So we're going to have x minus 2. I'm going to go ahead and put that in parentheses since I'm multiplying that now by the log 4 equal to the log of 35.6. Okay. What are you going to do first this time? Remember your goal is to get the x isolated. What's one thing we could do right now? No. Yes, you can think of it this way. This they're kind of stuck together. You're taking the x minus 2 times the log of 4. So the first thing we could do is divide by that log of 4. So let's do that. Okay. So if we do that, those log of 4s will cancel. We'll have an x minus 2 equal to all of this, the log of 35.6 divided by your log of 4.
2.577.
Thank you. Okay, and we're not done yet. Right, we need to do what? Yes, exactly. So you still got to finish up. Add a 2. Oh, I'm thinking ahead, aren't I? Sorry. So those would cancel. So we would get x equal to 4.577. All right. So very similar to the one you just did. It's just that we had a little extra step at the end.
So is it always going